In this episode I'm going to discuss analytical chemistry and what I'm going to be discussing throughout the series of this. So, what am I discussing? Infrared spectroscopy, nuclear magnetic resonance spectroscopy, mass spectroscopy, high performance liquid chromatography and gas chromatography. So for all of them, as you can see, I'm going to discuss how they work, what allows us to print out graphs of them, or the spectra as they're also called, and just basic background information so you understand the rest of how we interpret the graphs a lot better. So in infrared I'm going to discuss common diagnostic bands and absorptions. Now this is basically the peaks that we will see on the graph in the infrared, and it's used to determine what chemicals are. I'll tell you more about that when it comes. It'll probably be a few PowerPoints on that because it's a big topic. There's a lot of different diagnostic bands. NMR, I'm going to discuss carbon-13 and proton NMR. Splitting, which is normally unique to proton NMR, it's due to spin-spin coupling of protons. And ppm, or chemical shift, which is just another useful tool in determining the environment that these atoms find themselves in. Mass spec, I'm going to be discussing basic cleavage, which is just another word for how the molecule would break down in the mass spec machine. So I'm explaining all the different masses we get at peaks. High performance liquid chromatography and gas chromatography, quite similar. I'm only going to discuss how it works and the adjustments you make. I'll explain the graphs in the how it works section, and adjustments is to just increase the efficiency and the resolution of your machine. These are both quite commonly used in industry to determine purity of compounds. And I'll also explain using them all together diagnostically to determine the chemical identity of something, or just to confirm previous theory of the product you have produced. Anyway, I hope this will be a helpful series, and thank you for listening.